Q squared. Why are you going away?
That's the fun of
It's way more fun than helping.
Suck. Okay, so Q squared, Q, P squared, 2PQ. So the allele frequency, how are we going to figure this out? Okay, thank you. Find Q squared.
Take the number 396 divided by the total of 950.
Why 396?
the number of red cells.
So what's 396 divided by 557? 396 divided by 557?
No.
Why?
Because that's a total.
Total individual. So what do you get? Point.
0.416.
Okay. Q. Okay, look over at your neighbor's answer, Joseph, when you have a calculator in front of you.
Well, I rounded it so that was like,
0.64.
What are you doing?
I am watching.
Help me out, people.
oh, 113.
Okay, so the allele frequencies of each allele. The allele frequencies of each allele. Who's gonna give me this stupid answer?
Oh, P equals 0.64.
0.64, P equals 0.36. The expected genotypic frequencies.
Q squared equals 0.42. Q squared equals 0.13.
Good. Okay, so the number of heterozygous individuals you would predict to be in this population, bubble the number into the nearest whole number. How do you do this?
Take a QPQ value and multiply by
0.45 times.
Have someone talk louder. I hear them.
0.45 times
953.
953 equals what?
Wait, what?
Oh my gosh.
What now?
0.45 times 953. What? 428. Now how are we going to bubble that in? Grid left to right. So how am I going to do that?
428.
So 428.
No. Rounds up.
Well, what's the total number?
428.85.
428.85. Okay, so whole number. Oh my god, this is like elementary math. 429.
No.
No. Come on. The 4 goes to Louis. 90.
I want to write left to right. So 4, 2, 9. Hopefully you bubble it in a little bit better than I did. Yes.
If it's asking for like frequencies, would it be okay to actually put the R and or would you want the P and the Q?
You can go P equals 0.64 and or sorry, P equals 0.64, or Q equals 0.64 and P equals 0.36. Or you could go big R equals and little r equals, either one. The expected phenotypic frequencies. Someone. Q squared equals 0.416. Tan is 1 minus 0.416. So it's total number minus 0.416. This is just phenotypic frequencies, right? Okay, conditions happen to be really good for this year for breeding, and next year there are 1,245 young potential biology instructors. Assuming all of these would be in Hardy-Weinberg, how many would you expect to be red-sided and how many tan-sided? How would you do this? No, not chi-squared.
Multiply the total population by the expected phenotypic.
So
0.416 times 12.
0.416 times 1245 equals 522, 523. That would be a 3. And
518.
Joseph, learn your math. 518 to, yes.
I think some of them you already put 3 digits in some before. Right.
Oh, you mean these frequencies? You don't want to, you really don't want to round too early.
Oh.
I'm just saying the numbers that you guys tell me. You want about 3 digits in these numbers, unless they tell you otherwise. Okay, so what's the tan-sided?
727.
727. Like the airline.
Are we literally gonna have these after?
Yes.
Oh.
Yes, I'm bringing them down.
Not me, like a new calculator.
I hate this class. Okay, if we were to have 1,000 tan-sided individuals out of 1245, are we in Hardy-Weinberg equilibrium? How would you determine this? How would you test this? Chi-squared. Are we in Hardy-Weinberg equilibrium? Okay, so how are we going to figure it out? No, you can't do chi-squared yet.
We got find out how many
Ahmad, you're losing points in class. You're right. So how do I figure this out? The observed and expected. Well, okay. So, come on, help me out, people. What? Joseph, you're not on today.
1,064.
So we have red. Observed is 245. Expected is 518. Tan. So happy you know your numbers.
735.
What?
70, yeah, sorry. I got the wrong number.
What? O minus E squared divided by E. What do you get? I don't trust Joseph. Out of everyone in this room,
Oh no, I did like the square minus 5.
come on, guys.
273.
And you're using what calculator?
This one.
You are full of crap.
Did it in the
273. So what's going to happen? What does that mean?
Like your O minus E thing, right?
Yeah. O minus E, you gotta do the red one.
Oh, I thought that was the chi-squared value because I thought you guys were going to go faster than that.
Oh my gosh, you guys.
I thought we were going in order.
What is the chi-squared value?
246.394.
That's some reject right there.
246. So that means we reject, which means what?
Less than
There's an outside force playing a role. Okay, now you are going to shush your mouths and do the next two problems.
You should try putting your knee on the chair and see.
Could I not find that phone call? I would have gone to the bathroom.
Yeah, me too. Well, then just
But
take the chair.
Roll down the hallway.
Yeah, like get on your knees.
Do you have your cord, by the way?
Oh no, I don't.
Does anyone have an iPhone 5 cord?
Got a lightning charger? None of you have a lightning charger?
Sam does. No.
He's haggling.
You can get a Q.
How about a D plus? I'm gonna have like a 37%.
I just need this part. Dude!
Can we go over 5?
No! Okay. So, if a given population only the A and B alleles are present in the ABO systems, there are no individuals with type O or with O alleles. If 200 individuals have type A, which means what? They have to be what? Okay, there are no O alleles. So AA. 200 are AA, 75 are AB, and 25 are BB. So how are you going to set that up? Non-Mendelian genetics.
I said non.
So, what's my Q squared?
Divided by 2.66.
What's my P squared? Do I have to do P and Q for this? Actually, yes, I do, for the allelic frequencies.
0.8.
What is what?
Q.
Q, 0.812.
It's 0.18.
0.18.
Okay, do I have to do any more? No.
No, that's a number.
Easy peasy? Yes or no? Stop laughing.